So introduction to heat equation. We have the heat equation. Okay, heat equation is one of the interest PDE that describe the heat or flow of one-dimensional subject. Okay, kenapa one-dimensional? How do you know that? Okay, this is the equation of heat equation, the general form of heat equation, del U del T equals to K respect U squared, where K is heat constant. Why do you say that it's one-dimensional?
Del X square.
Okay, we only consider X. Bila kita sebut space variable, spatial variable, you ada X, ada paksi X, paksi Y, paksi Z. Kalau 3 dimension. Alright. So one dimension is you only look at one axis je lah, one side je lah, which is in this case X.
Oh, okay.
Okay, so you can just imagine that kalau you ambil pen tu ataupun apa-apa stick lah, you imagine that is you punya one dimensional subject. So you nak tengok heat distribution tu, okay, contohlah awak bayangkan ini awak punya pen okay, I'm sure that you are now holding a pen ataupun you just dengar. Okay. Alright. Okay, so you want to see heat distribution along this rod lah, kita panggil rod lah, yeah? Along this rod, okay, from x0 to x equals to L. What does it mean? The length of the rod is L, okay, and what is the heat distribution as time increases? Right? Okay. Beza PDE dengan ODE. If ODE, kalau you nak tengok spatial variable, you just look at the spatial variable without consider the time. Or if you want to look at the changes in with respect to time, you don't care about the X, the space. Alright. So in this PDE, you solve space variable atau spatial variable and time variable. You nak tengok macam mana perubahan suhu ni along the rod as time increases. Alright, okay. So imagine this is a rod. You have length of your pen, right? You know what is the length of your pen. So we have x equal to 0, the starting point, and x equals to L, L is the end point. Obviously, when you have this rod, it has two ends, right? Okay. Okay. So when x equal to 0 and when x equals to L, we call it as boundary. Okay?
Okay.
Okay. Then what is the changes of the heat as time increases, which means when T greater than 0. This is one example. When it says that U0T equal to 0, ULT equal to 0. At the starting point and at the end point, at the both ends, the heat is equal to 0. What does it mean? Both ends, boundary condition is 0. I say that you put both ends in a bowl of ice. Okay, now I change U0T equals to 100.
Put at the boiling water.
You give
Pressure cooker.
pressure cooker. Okay. Okay. Say lah boiling water. You letak your first starting point of your pan in a boiling water and the end point of your pan in a bowl of ice. Okay, now you understand, you cannot change that. Even though when you reach T equals to 100 seconds or 1000 seconds or million seconds, the boundary condition remains the same. You cannot change that. Right. Okay. What we call as initial condition. Bila sebut initial condition, it relates, okay. Kalau kita tahu ini kita panggil dia boundary condition. Alright. And the second one here, we call it as initial condition. So what do you want initial condition? Initial condition is the temperature or the heat along the rod when T equals to 0. Okay, when t equals to 0, you nak start you punya eksperimen kan?
Ah.
Okay, then you measure the temperature or the heat along the rod. Okay, when x equals to 1, x equals to 1 over L, contohlah. Okay, 1 over L. Alright, what is the heat? At time t equal to 0, what is the heat? At equals to 2 on L, up until when x equals to L. Alright, now you can differentiate what is boundary conditions and initial condition. Ada soalan? As I said to you guys, you're going to solve the same equation. So what makes the difference in the question is the value of the constant, K, okay, the value of L, the length of the rod, and the initial condition, and the boundary condition lah. Right, kosong ni mungkin boleh tukar macam saya kata tadi, at x equal to 0, u0t equals to 100. Okay, we can simply change that, right? And ux0 equals to fx. So fx here can be a exponential function, an exponential function. It can be a trigonometric function, or it can be a polynomial function. All right. Okay, then I will say that ux0 equals to fx, the initial condition, this is where you're going to see Fourier series. Okay, all right. Okay,